So now we're going to look at taking these complicated rational expressions and simplifying them. Okay, so they're fractions. So just like with numerical fractions, like I don't know, 5/10 or 32 24ths or something like that, you can always do some simplifying potentially. And so think about a really simple numerical fraction like 6/8. 6/8 can be simplified or reduced. And of course, sometimes we just think of it, you cancel them out, cancel a 2 out of each one, and you get 3/4, right? Divide them both by 2. But another way to think about it, instead of dividing, is to factor. You can factor the numerator, the 6, into 2 times 3, and you factor the 8 into 2 times 4. And if they share a common factor, the 2, you cancel, right? Anything that's shared between the top and the bottom can be canceled. And if the 2's cancel out, that's because anything divided by itself is 1. Then the remaining factors are the simplified form, 3/4, okay? So with rational expressions, it's a similar idea. We're still dealing with a fraction. So anytime you have common factors to the top and the bottom, you can cancel them. But they must be factors, okay? This canceling only works when we're multiplying. If we were adding something like, 6/8 is also, 6 is really 5 plus 1, and 8 is 5 plus 3. But you would never cancel the 5's here because it's not 1/3. You can't cancel when adding or subtracting. Okay, so this isn't helpful. You must have these in factored form. They have to be multiplied. So if I take sort of a basic example, something like x squared plus 6x minus 16, and I put that over x squared minus 4, then I can do some factoring and canceling. So this is a fraction, and again, to reduce this, if possible, we'd have to factor out the numerator and the denominator and cancel the common factors. So here I factor on top. Well, this is a polynomial, it's a trinomial. Lead coefficient is 1. So we'll look for factors of -16 that add up to 6. The values are +8, -2. So we're going to have x plus 8 and x minus 2 as the two factors on top. Now, it's often going to be the case that I'm going to assume you guys are getting very good at factoring polynomials. So some of these basic ones I'm not going to show any work on. I'll just put them up there because they should be pretty clear. If they're more difficult ones, I'll go ahead and show work on them. Here, this is a difference of squares. Difference of squares always factors into conjugates. So we'd have x plus 2 and x minus 2 as the factors of x squared minus 4. So x plus 2 and x minus 2. Now we have the polynomials in their factored form. In order to reduce, we have to cancel entire factors off as long as they're common to both the top and the bottom. Here, there is a factor common in x minus 2. We have one of them on top, one of them on the bottom. The entire factor has to cancel off. You cannot cancel parts of a factor. That wouldn't work. So those two cancel out, and we're left with x plus 8 over x plus 2. This is the simplified form. Now there is one little detail, it's actually a major detail, but it's something that's missed often, and I just want to point it out. We're not going to deal with it very much, but it is important to note. This original polynomial, or this original rational expression, if you think of it as a function, it has a domain that excludes both -2 and 2. This function, if you think of it as a function, has a domain that only excludes -2, okay? Here, both -2 and +2 make the bottom 0. Here, only the -2 does, okay? And that's because we canceled out the factor where the 2 makes the bottom 0. So these two expressions, the two rational expressions here, the big one and the smaller one, they're equal except at the point that was canceled out, except when x is equal to 2. When x is equal to 2, the bigger one doesn't have a point there, it's undefined. The smaller one does have a point there, it is defined. Okay, so if I plug in a 2 in this first polynomial, the bigger one, plug in positive 2, I'll get 4 plus 12 minus 16 is a 0 on top, and I get 4 minus 4, which is 0 on the bottom. 0 over 0 is undefined, so this would be undefined. If I plug in a 2 here, I get 2 plus 8 is 10, 2 plus 2 is 4, I get 10 over 4, which is 5/2. So I get a value on this one, it's undefined on this one, okay? So we want to be very careful that they're not actually equal. When you think of them as functions, they're equal so long as you're not looking at the one point or the one number that kind of gets canceled out here that changes. So here you've got an undefined point at 2, here you've got a defined point of 5/2 at 2, okay? Other than that, everywhere else, so there's an infinite number of points where they are the same. It's just at one point where one of them doesn't have a value and one of them does, okay? Because it only occurs once, we're going to write them in as equal, but technically they're only equal when x is not equal to that 2 that we canceled out, okay, or from the factor that we canceled out. Okay, because when you plug the 2 in, maybe this isn't clear, when you plug the 2 into this factor, you get a 0 on each of these, okay? Okay, so anyway, that's how you simplify a rational expression. And so we could do that with even more complicated rational expressions. You could do something like, I don't know, 3x squared minus 13x plus 4 all over, now I gotta think about how this is gonna factor out, so I can make another one here. Let's see, that's gonna be x. So let's do 9x squared minus 1. Okay, yeah, let's try that. I don't know. We're going to work this out. Hopefully it'll work out nicely. So on top, I have a trinomial whose lead coefficient is not 1. So I have to use the AC or modified AC method. I'll go through the modified AC method first. So remember, with the modified AC, I'm going to take this off to the side here, and then I'll put everything back in. Well, yeah, actually I should actually take it off to the side, and I'll work this downward. So just to do this factoring, you're going to get 3x in the first term and in the first term on the second one. And then I want to have the AC. I want to figure out what AC is. 3 times 4 is 12. So AC is 12. Factors of 12 that add up to negative 13 are negative 1 and negative 12. Okay. So I want to put in a minus 1 and a minus 12. There's no common factor in the first factor, but there is a common factor of 3 here, so I want to divide those out. Dividing that out gives me 3x minus 1 times x minus 4. Okay, so 3x minus 1 times x minus 4 will be the two factors in the numerator. Then I have my fraction. Then my denominator again is a difference of squares. And so I use the conjugates, 3x plus 1 and 3x minus 1, as the two factors of the conjugates, or the two factors of the difference of squares. Now I look at common factors. I have 3x minus 1 on top and on the bottom. So I want to cancel those common factors out. And the final answer then is going to be x minus 4 over 3x plus 1. Okay. Again, this simplified fraction or rational expression is equivalent to the original, except at the points where the top one is undefined and the bottom one is not. Namely, that's going to be where this canceled out term equals 0, or factor equals 0. It'd be like 1/3, I guess. Okay, so I'm not really worried about that. Right now, I just want you to be able to simplify. But when x is equal to 1/3, these two functions are technically not the same. Okay, we can even do some factoring and canceling by pulling out negatives, and that is something that you're likely to see on my math lab. If you had something like, let's do x squared minus 8x plus 16 over 12 minus 3x. Okay, so here's an example. Oh, is that right? Yeah, that's right. That'll work. I think we can make that happen. Okay, so on this one, I want to factor the numerator first, and then the denominator. Numerator, trinomial lead coefficient is 1. I could try to just factor by finding factors of 16 and add up to -8. This is also a perfect square trinomial. If you notice that the square root of 16 is 4, if you double it, you get the term in the middle. So this is a perfect square trinomial, which means the factored form is x minus 4 quantity squared, right? Or x minus 4, x minus 4. Think about factors of 16 and add up to -8 or -4, -4. So I put it in the exponent form. Then down here, these have a common factor of 3 I could pull out. So if I pull out a 3, I'm left with 4 minus x. Now, as it appears, as it occurs right here, it doesn't appear to have common factors. Here I have x minus 4 squared, here I have 3 and a 4 minus x. But I can actually make them have a common factor. To do that, on top here, maybe I'll just expand it to x minus 4 times x minus 4, just so you can see what's going on. It doesn't really matter as long as you're comfortable with reducing the exponent. On the bottom though, notice I have 4 minus x instead of x minus 4. The signs are different. So here I have a positive on the 4 versus a negative on the 4, a negative on the x versus a positive on the x. If I were to pull out a -3 instead of positive 3, it will change this to -4 plus x, right? If I were to pull out a -3 on that. Well, -4 plus x is the same as x minus 4. Right, that changes the sign. I just switch them around. So now I have positive x minus 4. Think about redistributing. -3 times x would give me the original -3x. -3 times -4 gives me the original 12. So by pulling out a negative, it changes both signs. And now I can cancel common factor of x minus 4. So those cancel. And it doesn't matter which one I cancel it with, but as long as I cancel it only with one of the factors. And so the final answer is going to be x minus 4 over -3. That's my simplified form. Okay. So again, these fractions, these very complicated fractions can and sometimes do simplify to much more simpler looking fractions.